Hello, hi everyone, welcome to Cloud Sprint. In this video, we are going to learn about what are managed instance groups, how are they different from unmanaged instance groups. We will also look at the features of MIG offers, which is auto scaling, auto healing, load balancer. We will do a hands-on lab, where we will see all these things in action, not just theoretical part. This video is very important. Make sure you watch it completely because whatever services you use on Google Cloud, whether it's Kubernetes or BigQuery or any other product, most of the services backbone is MIG. So if you understand MIGs really well, your life is really easy while you work on your projects. So basically, Compute Engine offers two kinds of managed and unmanaged. So far in the course, we have been using unmanaged instance groups. First of all, let's try to understand what is the difference between managed and unmanaged instance groups. Unmanaged instance groups lets you load balance across a fleet of VM that you manage yourself, which means we have to manage our instances, what is the size, how many times you want to keep it up, if you have to add servers, if you delete servers, everything is under our control, right? Google did not help us to manage those things. However, when we talk about managed instance groups are basically a collection of virtual machines that can be used as a single entity. Managed instance groups let you operate applications on multiple identical VMs. We can ensure that our applications hosted on MIG instances are highly available. We can also take advantage of automated MIG services like auto scaling, auto healing, regional, multi-region, multi-zone deployments, and automatic updating. So these concepts like auto healing, auto scaling, auto updating, these things are not something which you use day in, day out. So let's try to understand them one by one. What is auto healing? Whenever a service goes down, the VM will restart itself. Okay, the VM will kill itself without any manual intervention. It will restart itself and start serving the traffic. How to configure that? We'll see this in this video itself. Second is multi-zone. So you can have your one instance deployed in US Central 1, one instance in US East 1. So that's how you can distribute your workload across different zones within one application. What is load balancing? You can have multiple instances in different zones and you can distribute the traffic via load balancers. The fourth bit is around auto scaling. So whenever a peak load happens, you need to ensure that you're increasing the size of your fleet, which is your number of VMs should increase to accommodate the traffic. That's where auto scaling comes in. We'll try to see that auto scaling also in action. The last bit is auto updating. So whenever we have some safe type of updates, auto updating helps us to update our operating system, patching, those things are done. MIG instances are ideal for stateless serving, for all sort of batch workloads or stateful applications. That's the basic difference between managed and unmanaged instance group. You can also deploy newer versions without any downtime under managed instance group, which is MIG instances. Before we move to understand the managed instance group in detail, let's try to understand what is auto scaling. So suppose one of the example in terms of this IPL season, today IPL is happening. Okay, so whenever in your first and second over, suppose you are able to serve with two servers or entire traffic. In the third over, what happens, MS Dhoni or maybe a Virat Kohli comes to bat. Suddenly, the number of users will increase and you'll have to add 2 or 3 more servers to address the peak load. When they get out or the match is finished, the traffic will reduce gracefully. And then you have to shut down your servers to come back to the same load which you were able to serve when you started the match. That's the basic graph of auto scaling. As your demand grows, you have to scale your VMs. And as your demand falls down, you scale down your VMs, right? That's what auto scaling actually looks like. That's one of the example I thought to give you. Now let's go ahead and understand what it takes to create a managed instance group. The most basic part is instance template. If you have an instance template, you can create a managed instance group. You can also create it unmanaged. But what is instance template? Instance template is basically a resource that we can use to create virtual machines. Instance templates are a very convenient way to save a VM configuration. And then we can later create VMs, group of VMs or reservations later on. Why? Because it gives us a template And when we have to auto scale, we have everything ready. We just have to create one replica of it. And it's not us, we will configure it, Google will create it for you. That's the benefit of using MIG instances. So instance template basically will define what is the series and machine type you're using, service account, your boot disk, OS image. If you want to run a container image, just pass that. The labels, the startup script, network, everything, right? So you just figure out, you just set that, you set all these details in your templates, and it will boot up your disk. It will boot up your VM whenever you auto scale or descale or when you create it. So that template serves as a read-only copy. Very important concept. Instance templates are designed to create instances with identical configuration, so you cannot update the existing instance templates or change any template after you create it. So it becomes a read-only copy. So you just have to create another version if you want to make any changes. Okay, that's very important, and you cannot go ahead and change an instance template once it is submitted. To understand this, we are going to do a lab which has these steps. The first step is to create an instance template and to deploy Nginx with all required properties in multi-regions. Then we'll be creating an auto scaling. Then we'll be creating an auto scale managed instance group using that same instance template which we created in the first step. Third step is around creating a health check, then creating a load balancer, stopping the Nginx to see auto healing in action, increasing the load to see auto scaling in action, right? So this is the architecture we are going to do in lab. See you at the labs. First of all, we have to create an instance template to deploy Nginx with all required properties in multi-region. So what we'll do, we'll go ahead and create an instance. For that, we'll come to this, we'll come to the console and click on Compute Engine. Over here, you'll see instance template. As I mentioned, we have to create an instance template. Click on instance template, click on create instance template. You can give a meaningful name, say Cloud Sprint template. In series N1 and give me F1 micro, which is the most cheapest one. Okay, I'll go ahead. If you want to deploy a container with every VM, you can pass a container over here, but in this case we just want to use a startup script. So I'm not putting any container name here. I'm just using Debian as a image. I'm not changing any I'm not changing the service account, just keeping it default one, but if you want to choose, you can choose here. Everything is by default. I am going to allow HTTP and HTTPS. Next is advanced option. Network is, I'm putting it as default. What I want to add is management. In here, I want to pass a startup script, which will install Nginx and set it up for me. For that, I'm just going to use this script. What it will do, it will first of all update the OS. It will install Nginx, start the service, and then it will replace this HTML file with the host name. So we will know that which host name we are being served the traffic from. Nothing else. I don't want to change anything. It should be standard. Let's click on create. So this will create an instance template very quickly for me. Okay, once the template is created, we can move to the second step. Meanwhile, this template is getting created, we will go ahead and check what is the second step is we need to create an auto scaled managed instance group using the same instance template. Now you can see this instance template is created with Cloud Sprint template name, machine type, image name, disk, and everything else is here. You can create a virtual machine from here, or you can create an instance group from here. Okay, let's go to instance groups. We don't have any instance group existing for now. The second step was to create an instance group using the same template. So click on create instance group. You can see here many type of options you have. First is unmanaged instance group, which is we're not going to use in this case. We are going to use the managed one. Then there are two types within managed. It's stateless and stateful. Stateless is basically for serving and batch processing. Stateful is used for databases or legacy applications. I have to choose the instance template now, okay, which we just created, Cloud Sprint template. What I'm going to do is just let it be, no changes. Now the requirement was I have to create this in multi-zones. So what is the meaning of multi-zone? Suppose you have customers from different areas within US. You can choose to serve few of your servers can be in 1C area, few of your servers can be 1F zones. So you can serve the customers from all these areas in a better way to avoid latency. They can have the better user experience. So I'm going to choose these two. You can choose more if you need. And target distribution shape is even or balanced, so I'll just put even for now. Okay, next step is auto scaling. In a nutshell, auto scaling is all about automatically adding and removing instances to the group for period of high and lows. What I'm going to say, I need 2 minimum instances and maximum 4. Okay, minimum means that every time these number of instances will be running. Maximum is irrespective of whatever the load is. I'm not asking you to create more than 4 VMs. While working with free tier, you might get issues when you try to create more than your quota, which is by default, I think 8. So try to test it within that range itself. Now, when you want the auto scaling to happen, you want signal, right? It will work on an event. So by default, it is if CPU utilization is more than 60%, it will create another instance. Now, what is target CPU utilization? 60, 50, 40, 80. You can choose depending on your application, how much time your new node is taking to be ready. You can choose depending on that. I'll click on done. If I want to add another signal, I can choose HTTP load balancing unit. If based on some event, I want to add some. Suppose I want that when somebody uploads a file, a VM should get added to this node pool to process that request. So that I can do here. Any monitoring metrics I can check here. So you can add different type of signals. In this example, we are using CPU utilization. Then you have cooldown period. This is very, very important concept. This basically specifies that how long it is going to take your app to initialize. Okay, how long it is going to take your app to initialize from boot up time until it is ready to serve. What happens? You add a server. Okay, you add a server and you are still not able to serve the traffic from that VM because your application is not set up properly. That will give a 404 error, and that's a bad user experience. So you should ensure once your website, once your server is up and ready, it's already boot up, how much time it will take your app to initialize. In this case, it is Nginx. All right. So in this case, we are saying 60 seconds. I believe 60 seconds is more than enough to for Nginx to set it up and get started. Next is about keeping the instance lifecycle. I'm not going to change anything. Yep. Next bit is around auto healing. What is auto healing? Auto healing will recreate VM instances if an application cannot be reached by the health check. So health check is an entry. Let's create a new health check. Say cloud sprint etc. What it will do, it will send a request every seconds, whatever you configure. So in this case, the criteria we're going to define is check interval is every 5 seconds, timeout is 5 seconds, healthy threshold 2 consecutive successes, unhealthy threshold 2 consecutive successes. So basically, if twice, it will try 2 times. Okay, if your service is not responding, it will mark your instance as unhealthy, and based on that KPI, your instance will be recreated. That is the benefit of auto healing. So if this kind of situation is happening at 1 a.m. or 3 a.m., nobody have to sit manually and recover that. This auto healing feature will take care of your instance. It will remove the node which is not able to serve and create a new one. That's the benefit of auto healing. Again, we have 300 seconds of initial delay to ensure that it is warmed up. We just chose the template, the location, auto scaling policies on 60%, auto healing policies on port 80, and I'm going to create the instance group. It will take some time to get created. I'll be back once it is ready. Okay, so within 2 minutes, the instance is created. You can see we had requested minimum 2 number of instances. It was created at this time. The instance is ready. Template we used is this. And instances are healthy. We have used this CS health check for the health check for auto healing basically. And for auto scaling, we have said that whenever CPU utilization is more than 60%, just scale one, add one more node, and maximum can be 4. So these are configurations we did while installing it. Let's go ahead and check if our Nginx is ready to be served. Okay, you can see you are being served from Google. Welcome to Google Cloud Platform. You're served from this instance group, which is 7p67, right? 7p67. And if you choose the other one, which is this, you will get that you're being served from 641. Okay, why I change this script like this? Because when you use load balancer, you'll be able to see this in action, that how the traffic is balanced between two different VMs deployed in different zones. Like this is deployed in C, this is deployed in F. So when you get customers from C, this will serve the request. When you get from this zone, this will serve request. So they can have a better user experience. That's the benefit of having multi-zone deployments to have a highly available application. Coming back to here, we have created an instance template in multi-region, installed Nginx, auto-scaled manage instance group using the instance template. The third step was to create the health check for auto-healing. We also did that. The fourth step is to create a load balancer to distribute the traffic among VMs added. This is the architecture diagram. That's what we have to do. So we are done with the right bit where we have set up the manage instance group. Now we have to create a load balancer so customers can directly reach to this load balancer. We can serve them from these different VMs hosted in different zones. Let's go ahead and create a load balancer. To create a load balancer, we need to go to network services, load balancing. Load balancing, create a load balancer. Here you'll get three types of load balancer. While we study load balancers in detail, I'll be showcasing all the examples, but just for now you can understand we'll be using HTTPS because this is mostly used for internet facing or internal single or multi-regional kind of application. Click on start configuration to create one. The first thing is internet to my VM. Yes, the second option could be between my VMs, but I need from internet to my VM. Next is global HTTP load balancer classic. The classic one is not having the traffic redirector rules, so we should use the newer one, which we never know, we might need the traffic redirector rule as well in future. Click on continue. You can select a name, front end, protocol, port will be 80, done. Okay, we have added front end IP and port. Next is backend configurations. In backend configurations, we have to create a backend service. Let's click on create a backend service. I'll say cloud CS backend service. Backend type can be instance group, it can be serverless, it can be private, service connect, hybrid. These all are big options. Okay, you can choose as you need. Tomorrow when you extensively work, you can choose them. Backend type, in this example, I'm going to choose instance groups. HTTP, timeout is 30 seconds. New instance group. So this is the instance group which we have created. I'm saying port number is 80. Port number is 80. Okay, I don't want CDN in this case. Health check. I'm saying okay, yes, I have health check. I'll use CS health check. No security policy for now. Click on create. Say okay. So I have said that my front end configuration is there. As a backend configuration, I have added my instance group. So whatever I have hosted on my instance group, that can be served here. I'll give a name and I click on create. So this will create a load balancer for me, which has these two VMs added as their backend. All right, so this load balancer creation is completed. We'll open this and see if we are able to open the website. Okay, perfect. So we are being served from this instance 7p67. Okay, so you can see that we are being served from 7p67, this one. Okay, this completes the step 4 as well. Okay, you can see we have created a load balancer, hosted a compute engine with Nginx. We are able to create a health check. We'll see that also in action now. I'm going to show you two steps. First is stopping the Nginx. This will help us see auto healing in action. Also how a load balancer helps us to route the traffic to a different node whenever something is not healthy. You can see now we are being served from 7p67 VM. So I'll just log in here, SSH. Okay, I am here now. What I need to do is, first of all, what I'll do, I'll stop the Nginx service. What I'm doing, I'm stopping the Nginx service. Okay, you can see it's stopped. You can see it's dead. So we stopped the Nginx service, which means this particular VM, which is SP67, is not able to serve the traffic. Now two things will happen. Auto healing will come into the action. First of all, see how load balancer will help us. So far we were being served from this particular VM. You can see it's dead now. It's being recreated. That is the benefit of auto healing. So somehow your service stopped working and you are not able to serve the traffic from that VM. So auto healing will check that, okay, instance is not healthy. This health check will check it and recreate your VM. That's the first part of auto healing. The second bit is now we have only one VM running, which means that traffic which was being served from this VM should shift to this VM. That's why we pay for load balancer. Let's go ahead and check if that is happening. Enter. Yes, you can see the traffic has shifted to 641 VM, which is the active and healthy one. Right, that is the benefit of using load balancers. So load balancers automatically, through health check, got to know that this 7P67 is unhealthy and I need to shift the traffic to 641 for a seamless migration. That is the benefit of using auto healing with load balancers. Right, I hope you are able to follow this. Now with auto healing, this VM is being recreated. It will take approx 2 to 3 minutes to get recreated, set it up, depending how much delay we have given. And yeah, you can also see this instance health is down to 50%. This VM is recreated and it will be up and running. Once it is up and running, it will again start serving the traffic. But for now, we will have to serve all the traffic from this 641 VM and this will be served for entire zone. Unless this zone US Central 1 CVM comes back, we'll be serving all the traffic from US Central 1F. That's how you design a highly available architecture. Even if your zone goes down, you can still serve your customers. You can see now it is updating, which means this instance is being replaced. So far, we have completed all these steps. The only step remaining is to increase the load and see auto scaling in action. Once we are recovered from the auto healing, once auto healing VM is available, we will see auto scaling in action. So you can see finally with this, it is showing that one VM is active, serving the traffic, another one is not healthy, and it is being recreated. It is being recreated and it is being updated with a new. It is using the same instance template. All right, so perfect. So it's ready to again serve our traffic and it has recovered itself. It has healed itself. Let's go back and try to access it. 641. Yes, it is back to serve, back and serving the traffic healthy. Okay, that's how auto healing works, and that is how it is going to save you a lot of midnights where you can peacefully sleep and let auto healing take its due own course. And also you understood that how load balancer will help you to balance the traffic between these two or more VMs. And if one in zone goes down, you can serve the traffic from other zone just by simple configurations, which we did in this video. The last bit in this video I want to cover is auto scaling. To manage auto scaling, first of all, simply understand we have said maximum 4 instances we can get added, and once our CPU utilization goes beyond 60%, then only add VMs. So what I'm going to do, since I don't have a live traffic, I'm going to simulate a traffic. To simulate the traffic, what I'm going to do, I'm going to install stress. It will basically simulate a load for me. Let me install it. Okay, it is installed. I'm going to increase the load. This will create simulated load and stress the CPU, and it will increase the significant timeout. Okay, let me click enter. Let's see how it is increasing the load. And there are many ways to see it. You can just go to this particular VM. What it will do, it will increase your load. And how to see that, you can click on observability and just see your instance increasing. Then note one thing, even if one VM utilization is 100%, overall utilization has to increase. Then only auto scaling will work. It's not like you have just one VM running at 80%, overall it's still less than 60. It is not going to add any servers. So for overall monitoring, we'll come here. Okay, perfect. You can see now stress command is completed and it increased my load more than 60%, and I have 2 more VMs added. It is of course not in healthy condition, but it is being verified. So I have 4 instances. Auto scaling is an action kicked in. initial delay which we have put, that is, it is warming up the instances, and it will start serving the traffic once it is available and ready to be served. Right? A simple load. I just increase the load and you can see auto scaling happening in action without any changes. So okay, you can see we have got two more friends to help us to serve with this load, and we are able to quickly add two more servers. Go ahead and see if we can get service from new VMs. You can also check the current load. You can see the current load is decreasing. So the moment overall utilization comes below 60%, these two new nodes will again come back to our minimum in configuration, which is 2. That is what I explained, that auto scaling happens. So when you have load, you add the servers. When the load is gone, you remove them automatically. You don't do anything, you just configure the KPIs, and Google Cloud MIG Instances will help you to do that. You can also see we are being served from new VMs now. Okay, 1N was not there, again 1641. We are being balanced 7P67, so it is just shifting the traffic to new VMs, and whatever is available, it is being served from there. Okay, now I'm not going to do anything. I'll just wait for the load to settle down. Once load is settled down, these two VMs should go away, which we just added as a auto scaling. I'll be back once it scales down. Okay, now you can see the load has gone down and it has started updating the VMs. So first thing it is doing, it is deleting the 4th VM, which was just added as it started deleting this one as well, right? So that's how the moment the load got reduced, it is deleting these two VMs, and we'll be left with the minimum configuration, which is 2, right? See, those 2 instances have been removed, and we are going back to 2. Just to give you a recap, we created instance template, we created an instance group, we created a load balancer, we created a health check, tested auto healing, we created auto scaling policies, and we have tested auto scaling. Hope this was an informative video, and you are going to go ahead and try your hands on this lab. Thanks for watching. Alright, so this concludes the MIG instance group. I hope you liked the video, and if there's any question, just please drop a comment and let's try to discuss them. Yeah, thanks for watching. See you in the next one. Bye.